Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Combined Science Physics Paper 2 Higher Tier from 2023. Question number 2 is on forces. A student investigated how the acceleration of a trolley is affected by the force acting on the trolley. So here you have the student is investigating how the acceleration, which is A, is affected by the force. So this equipment is testing Newton's second law. Now, second law, which is F equals ma, which is a required practical. So you have a trolley on a runway, which is slightly inclined. Figure 3 shows some of the equipment. So you have the trolley and the runway, which is on a table. And the question is asking, describe a method the student could use. So what is the student trying to do? They are trying to investigate what is the relationship between the force and the acceleration. So they're going to keep the mass of the trolley the same. So how would you do it? So you would want to apply a force on the trolley by attaching a hanging mass on the side over here. So for that you would need a pulley and then attach a thread and then attach a hanging mass over here, right? And you would have slotted masses here, and you would move the masses from the trolley into the hanging mass so that you're applying the force, which is W, which is the mass multiplied by the gravity, which is G equals 9.81. So how would you do it? So you would you set it up as shown. You would change different masses. You would remove the mass from the trolley and slowly add one by one over here and let the trolley go down the runway. So in order for you to find the acceleration, you can actually work out the force by multiplying the mass with the gravitational field strength, which is 9.81. In order to find the acceleration, you can find the acceleration using the equation. Acceleration is change in velocity, or final velocity minus initial velocity divided by the time. So you could mark a point A and then B on the runway, and time how long it takes for the trolley to go down this runway with this hanging mass. And you can work out the speed, which is the distance again between A to B, and divided by the time. You could use a stopwatch to measure the time. The initial velocity is going to be 0. What you're measuring is actually the average velocity. It still will be okay to work out the acceleration, and then you can plot a graph of force versus acceleration to find. So if you were to draw a graph of force versus acceleration, actually the force is going to be here and the acceleration is over there. So that means the gradient is y over x should be force over acceleration will give me the mass, which is going to be constant. So it should be a straight line going through the axis of 0. So how do we answer a question like this? Now you could also use a light gauge to measure the speed at A and then another light gate to measure the speed at B and work out the acceleration using the light gate itself. So here's how you would write an answer. First of all, you need to describe how you're going to set up the equipment and then the measurements that you're going to take. So method of varying the force: first, clamp a pulley onto the edge of the desk and attach a string to the trolley and place the string over the pulley. Attach a mass holder onto the string or vary the height of the runway using wooden blocks. So you can, without adding the weights on the side, you can actually just increase the height of the ramp as well, but with the weights is actually much better. The measurements you would take: place a slotted mass on the mass holder, use W equals mg to calculate the force, which is G equals 9.8. Mark the starting and finishing points of the trolley on the runway. Measure the distance between the two marks with a meter rule. So you're mentioning a meter rule here. Time how long it takes to travel between the two marks with a stopwatch. And use the equation V, the speed equals the distance divided by the time, and acceleration is the change in velocity divided by the time. So that would give you the acceleration. You could also mention that you can use a light gate to determine the time and speed, and let the computer or the data logger to calculate the acceleration. And the last point is to say repeat for different masses and slots. Although they're not expecting you to mention about drawing the graph, or you could still mention about drawing a graph. And the whole idea is actually to change the force and find the acceleration for different forces applied on the trolley. You could also include a method where you are talking about using a ticker timer as well. Generally, that can be a bit tricky. The two methods that I have discussed here are the best ones. Next question. Table 1 shows one set of results in a similar investigation. Resultant force in newtons is 1.2 newtons and the acceleration is 1.6. Which of Newton's laws predicts that the acceleration of a trolley, so acceleration, is proportional to the resultant force? That's Newton's second law, because that's the equation F equals ma. It's worthwhile reviewing what Newton's first law and third law is as well. In simple words, Newton's third law is every force has an equal and opposite reaction force, and Newton's first law is if the resultant force is zero, then either it's stationary or moving at constant velocity. 2.3. Determine the acceleration of the trolley when the resultant force is 3.6. So they're asking you to calculate the acceleration. Now you can use the equation F equals ma. Now we don't know the mass, so we can actually use the values given above from here. So resultant force is 1.2 and acceleration is 1.6. So 1.2 equals m times 1.6. So the mass of the trolley is 1.2 divided by 1.6. That gives me 0.75 kilogram. Then I can use this in the equation again. F equals ma. Mass is 0.75 multiplied by 3.6, and that gives me an answer of 4.8 meters per second squared. 0.8. Next question. Use the equation sheet to answer questions 2.4 and 2.5. Write down the equation that links acceleration, mass, and resultant force. You can write it as a word equation or a symbol equation. I would always write the word equation. That way, if you're writing the symbol equation, and if you make a small mistake, you're not going to lose that mark. The resultant force of 0.42 newtons acts on a different trolley. So you have a different trolley now with a force of 0.42 and an acceleration of 1.2. Calculate the mass. So using the above equation, F equals ma. Force is 0.42 multiplied equals the mass is what you're trying to find, multiplied by 1.2. So the mass is equal to 0.42 divided by 1.2, which is 0.35 kilogram. 0.35 kilograms. That brings us to the end of question number 2, and I will see you in question number 3.